Thank you, everybody, for joining. My name is Ado Kukic. I am the Director of DevRel here at Sourcegraph. And today we're going to talk about chat-oriented programming, or CHOP, and we're going to see it in action. We'll kick things off in just about a minute or two just to give everybody time to get in. But while we wait, where is everybody tuning in from? I myself am located in Las Vegas at the moment. And with me, I have Justin in the background who's helping with the comments. And Justin is based out of LA. So it looks like we got Neil from Atlanta, welcome. Portland, Greece, Phoenix, Seattle, Austin, Texas, Poland. Hey, welcome, Camille. Thank you for joining. Cincinnati, San Francisco, represented. Alberta, Canada, welcome, welcome. Another one from Seattle. Awesome. So it looks like we have a pretty good crowd, and I think we can kick it off. I want to get into all of the content today, and I want to show plenty of demos and take as many questions as possible. So we'll kick things off by talking about what is CHOP, or what is chat-oriented programming. And this was a term that Steve Yegi coined in a blog post a couple months ago, and he referred to CHOP as coding via iterative prompt refinement. And really what this means is using the large language model as your first point of contact when it comes to solving coding challenges. So instead of going to Google to search for how to do XYZ, you would go to ChatGPT or Claude. And this type of coding has really become popular over the last couple of months, especially since the release of GPT 4.0 and Claude 3.5 Sonnet. These state-of-the-art LLMs, foundational LLMs, have really reached a new level of understanding and a new level of capability where coding via iterative prompt refinement becomes a reality as opposed to a dream. And when it comes to CHOP, this is an evolving paradigm. This isn't something that we just came up with, out of the blue. And, it took us some time to get to CHOP. Before CHOP, we had, way back in the day, and I feel like I am I made the cutoff of the generation that actually used books and, read paper books to learn how to program. So if we look at, book-oriented programming, or BOOP, way back in the late 1900s, like, 1995, 1996, people used to look at books to reference, to learn programming languages, to learn concepts, and that was the way things were done. And then Google came on the scene, and Google had a really, really powerful search engine, and a lot of people wrote a lot of really wonderful blog posts. So Goop became the standard way of solving coding challenges. So you would use Google as your first point of contact when trying to find relevant content to solve your coding problems. A couple years later, we had Stack Overflow come on the scene, and we had Soup. So leveraging the Stack Overflow community to solve our coding challenges and problems. And when it comes to Stack Overflow, when it comes to Google, when it comes to referencing books, all of these methods were really, really good and were kind of the standard at the time. But if you've been programming for 10, 15, 20 years, you'll know that the challenges of finding an exact problem to your exact solution. There's been so many times where I've needed to solve a database-related problem or needed to solve a caching problem, and the resources I could find on Google or the resources that I could find on Stack Overflow were close, but not quite there. So I would have to spend a ton of time reading what the problem was, understanding what the solution was, and then applying it back to my to the problem at hand that I was trying to solve. And with CHOP, we are relying on AI or LLMs to provide a tailored solution, a specific answer to our specific problem. And this is really kind of the basis of how Chop works. Instead of first having to go to Stack Overflow or having to go to Google or having to use an external resource, you just ask the LLM and you provided your code, and it is going to give you a tailored solution, a tailored answer, looking at your code, looking at what you are trying to solve. And these days, it does it really, really well. In his blog post and in a video that Steve Yegi recently did, he called having to use Google search a failure mechanism, meaning that if you have to use Google right now to solve a coding challenge, it's because you weren't able to find a solution through an LLM. So hopefully in this talk, once we get into the demos, it becomes apparent why Chop is so powerful and why it is the new paradigm when it comes to coding. So let's take a look at the traditional coding flow. And I think many of us who are engineers are going to, I think this traditional coding flow is really going to resonate with how most developers work. The first thing you have to do is understand the issue. So, you read the Jira ticket, you read the PRD, you read, you try to understand what issue you are trying to solve. You get your requirements, you get the bug report. And then you have to understand the relevant code base and the relevant context for how to go about making this change. So you have to go and open up your codes directory, look into relevant files. The first time is probably not going to be the right file, so you're going to be cross-referencing a bunch. Once you understand what code it is, how it's interacting with the rest of the system, then you're going to jump into researching a solution. And this is in those, Goop or Boop or Soup paradigms where you would open up your web browser, you would start searching, I'm trying to, build a Redis queue, or I'm trying to figure out why this query in MongoDB doesn't work. So let me go search, and hopefully somebody else had this issue and I can learn from them. At this point, then you're finally ready to sit down to write and test the code. So you have a solution in mind. You might do a little copy and pasting. You might, kind of draw from your own experience and actually start writing the code. And there was a recent report that came out that said software engineers, typically spend only about 15 to 20% of their time actually sitting down and writing code. The rest of it is spent in understanding the issues, in understanding the code base, in helping other developers onboard and things like that. So hopefully with Chop, you're able to spend much more time writing and testing than doing all of the other things around programming. Once your code is written and you've tested it, you might write some tests for it additionally to make sure that, once it's built into the broader application, it still continues to work. Then you get to the code review stage. So in the code review, your manager or your peer will review the code, make sure that they are happy with it, make sure that it aligns with with your company standards. And then finally, you can ship it, document it, and go back to step one, understanding the next issue, getting the next bug report, the next feature request, and repeating this process. So that's the traditional coding flow that most of us engineers are used to. In the chat-oriented programming flow, we can kind of really simplify it to 3 steps. Understand the issue, write the code, and ship the code. And the idea here is that we can use AI and we can use LLMs in all 3 of these stages and have the AI, have the LLM do most of the work for us so that we can just focus on delivering the features, solving the issues, while the underlying LLM gives us just-in-time solutions for our problems. So Chop can be used in feature development, in debugging, but there are plenty of additional use cases for Chop as well. So code familiarization and onboarding is a very popular use case. How many times have you jumped into a code base to debug an issue and realized that this code has not been touched in years, or the team that worked on this project is no longer with the company or has moved on to bigger and better things. So you spend a day, a week, a month trying to understand what the code is doing, how it's working before you're able to be productive in it. Additionally, testing and documentation. Writing unit tests is one of those things that needs to be done, but is oftentimes overlooked or just kind of done because it needs to be done. But with AI and with LLMs, we can automate a lot of this, as well as documenting our code. LLMs do a really, really good job of summarizing information and just kind of restructuring it in natural language, which lends itself really well to documentation. And then finally, code migration and modernization is another really powerful use case of CHOP. You might be working in a older library or an older language version that you want to migrate to a new version. CHOP can really help with this because it more than likely has an understanding of what the concepts of syntax, structure, APIs of an older library are versus what the new library is, and it is able to very easily and very quickly kind of give you the updated code while maintaining the same level of functionality. And we'll see some of that in the demos as well. And before we get into the demos, I do want to just share this slide. This was a slide that Ron Keesing from Lido shared at one of our OpenAI Summit events on how one team within his company is changing the way that they work before CHOP, before using Cody and after using Cody. So they would spend before Cody, before LLMs, they would spend about 35% of their time reading and orienting and understanding the issue and understanding the code base. Post-CHOP, they spend about 20%. And then helping others took up a significant amount of time, 25%. After Cody, they were able to reduce that down to 5%, where you can ask Cody first, and Cody will more than likely give you the starting point or point you to the right file at the right time to be able to do your job. But there are cases if it's a very, very large code base, or if it's a very niche and kind of unique problem, where you still might need help from an engineering manager or somebody more familiar with the code base. Documentation going from 15% to 5%. And the number that makes me the happiest is seeing the coding and debugging time go from 25% to 50%. So out of those, 6 items, coding and debugging and kind of the being able to write code, engineers are able to dedicate half of their time to it. And then writing tests and performing code reviews, dedicating 10% of their time, whereas in the past, they were not doing it at all. So more time is being spent on higher value tasks as opposed to reading and orienting and helping others orient themselves around a code base. So how do we get started with CHOP? There are a couple of different ways we can leverage CHOP, and we can, the kind of intro to CHOP would be using the in-browser or a specific app experience, like using ChatGPT or, Anthropic's Claude. We can use it in browser with open source context. So with Cody, we have the capability to pull in context from open source repositories for you. And this works great, especially if you're onboarding and you're working with a new and unfamiliar library. It might be great to be able to ask specific questions around that open source repository. And then finally, the most powerful way to get started with CHOP is in your editor with your context, with your code. And we're going to see plenty of examples of how you can do that as well. So let's take a look at a couple of these examples, and we'll go from super simple to more complex, and then to very, very complex. So I'll close out the slides here, and let's show an example of how we can leverage LLMs to give us a starting point for building our applications. Now, my wife and I, we are in the process of moving and buying a house, and I really want to figure out what my monthly payment is going to be, what I can afford, and things like that. So I had the idea of, why don't I build my own mortgage calculator that I could very easily play around with a number of the variables and have a really, really tailored experience. And I can open up my code editor and write this code, but let's do it in the CHOP methodology. So the first thing I'll do is I'll open up the ChatGPT app here, and we're using the 4.0 model. And I can ask ChatGPT, I want to create a mortgage calculator application. And let me see if I could zoom in here a little bit. So just asking ChatGPT this question of, hey, I want to create a mortgage calculator application, kind of gives me a starting point of what I need to know. So it's giving me, defining the features. It's giving me the basic formula to calculate what a mortgage payment might look like, giving me the steps to choose my development stack, HTML, CSS, building the user interface, implementing the logic, et cetera, et cetera. But this isn't exactly what I want. I mean, this is a great starting point for me to understand what is needed to build this application, but I want to use the LLM to actually build the application for me. So I could follow up here and ask ChatGPT to give me, to give me the code for this, or I can go directly into my code editor and just use that as a starting point. So let's do that instead. I'll open up Visual Studio Code, and I have opened up this CHOP mortgage calculator application, and this is just a clean and empty Create React app application that has no functionality whatsoever other than the welcome page. And if we start it up, we can say npm start. It's going to load the application, and all we see is kind of the default React edit source app to save the reload to get started. So I can go in and open up my app.js file. And just to answer Martina's question in the comments, this session is going to be recorded, and everybody that signed up will get the recording either later this afternoon or tomorrow. So we have our kind of starting point here. We've downloaded the dependencies, we built the application, but it doesn't have any features and functionality. And again, I could start building out my application. I could reference ChatGPT here and say, okay, I've chosen my tech stack. I'm going to use React. What do I need to do? I need to capture the loan amount, the interest rate, the terms. So I could start, knocking these things off one by one and implementing the functionality. Or I could open up the chat window here and ask Cody, ask an LLM. In this case, I'll be using Claude 3.5 Sonnet, but I could use GPT-4o, Gemini Pro, Claude Opus, any of these supported models, and ask it the same question. And the question that I want to ask is, I want to build a mortgage calculator application. Let's just ask that. So we are additionally using Cody's context here. So we've included the entire repository here. So this current repository means that Cody will take a look at all of the files that we have, as well as the app.js file. But since none of the code here is really super relevant to us other than identifying that we are building a React.js application, it's not as powerful, but we can see which context was pulled in from our application. So source app, so all 25 lines of this, the README, and Cody was able to use all of this context to figure out that we are building a React.js application, and it gave us a bunch of code for how to build this application. So before I continue, let's take a look at the questions. So Caesar asked, what is the difference between the models? So the difference between the models is really giving you the choice to choose which model you want to use. And in my experience, I've noticed that, Claude 3.5 Sonnet is, in my experience, a little better at code generation tasks, where ChatGPT or GPT-4o is much better when it comes to documenting and giving you kind of natural language explanations. But with Cody, we kind of want to give you the choice to choose which LLM works best for you. And we're always adding new LLMs, as soon as a new LLM comes out that has promising use cases for code, we added just to give you that choice. And then Neil asked, is the current file included by default, or did you manually add it, or did you manually include the app.js file? So by default, it is going to add the current open file as well as the directory, but you don't have to use any of them. You can easily delete it or add additional files with the add syntax. So I can say, if I just wanted, the CSS file, I could include that in my context, or not include any context at all, and just kind of have a direct conversation with the LLM like I would in the ChatGPT app. So getting back to the response that we received here, we asked Claude 3.5 Sonnet, I want to build a mortgage calculator application. And Claude responded with, certainly, I'd be happy to help. And I see that you're using React. So here's some code to get you started. And the great thing about Cody is we recently added this apply functionality. So you can hit apply, and it's going to go look at the correct file. In this case, it's going to be the app.js, and it's going to line by line figure out what new code needs to be added and removed, and it's going to give us a diff, so we can accept and reject individual changes it's making, or at the very top here, we can hit accept all just to get all of those changes implemented. And so we did that. Let's hit save and go back to our application here. And now we've got a mortgage calculator. It's not very pretty, but we'll get there. And let's say we are buying a $300,000 house at a 6% interest rate with 30-year loan terms. If we calculate that, we'll get a monthly payment of $1,798.65. So this is a very great start, and we've got a great starting point for our application. And we didn't write a single line of code. We just asked Cody to give us this starting point, give us this application. But let's say we wanted to make it more complex, right? So here we're just taking the principal, the interest rate, the loan terms. Let's say we also wanted to provide like an amortization table to show, how much money is going to interest versus principal over the payments. So I can go down here and ask a follow-up question. And in this case, I'll still use the current file as context, app.js, and I'll say, can you also include an amortization table for the term of the loan? So again, we're using Claude 3.5 Sonnet in our example, and we get certainly. So it's going to go look at our current code that we have and update the relevant pieces to give us the amortization table. And then it also explains what it's going to do. So again, we can apply these changes, or we can copy and paste it if we wanted to. But let's just hit apply again. And Cody's going to go through all of the changes in our code base, find the most relevant ones, and find where it needs to make updates, give us that diff where we, as the developer, can accept and reject the individual changes. So I can accept this, accept that, accept this. So all of our changes are accepted. We'll hit save and go back to our application. And let's recalculate the principal amount. We said 300,000, 6% interest over 30 years. And now when we calculate the payment, we still get the same payment, $1,798.65, but we also get this amortization schedule showing us that, our first month payment, 300 is going to go to principal, then 298, then 300, 301, 303, et cetera, et cetera, et cetera. So not too bad, not a bad start. One other change that I might want to make to this application is for our balance here, we're getting a number in the hundreds of thousands, and I would like to have a comma separator every 3 digits to make it a little bit easier to read. So again, I could go in and ask Cody to do it in the chat, or I can go to the table itself, to the balance, or actually even here, and say Command K, and that's just going to highlight the current function, and I can give it further instructions. So I can say for the balance, can you have the value comma separated? Maybe not the best instructions, but let's see if it'll understand it. So here Cody's doing a very similar thing it did in the chat, except it's just going to make the changes kind of right off the bat. So we can see here that the only change that we're making is our balance. We're kind of localizing it to the US, still showing the number of fractions. And we'll accept this change. Accept it, save it, and go back to our application, refresh, and let's do this one more time. Calculate, and now we get a separator, so makes it a little bit easier to read. So we've built this entire application, in about 5 to 10 minutes, and it's working great. We have a ton of functionality. But we can go even deeper into the feature set here. So let's say we wanted to maybe have a breakdown of where our payment is going. But first, the monthly payment isn't the only thing that goes into your mortgage calculator. You'll also likely have, homeowners insurance and real estate taxes. So let's go and ask Cody to add that functionality. So we can either go in our chat or up here. And actually, before we do that, Neil asked, what would happen if you asked Cody to increase the spacing above the calculate button? So that is a very good question. Let's see how that would work. So here, our UI isn't really the greatest. So we could go to where the calculate button is. Calculate. So we have this calculate button here. So I could highlight this and say, do an edit, add extra margin and spacing around this button. So here we're just highlighting a specific part, and here, it's going to do an inline style to give us a little extra spacing. And that looks okay, but that's not the greatest. One way we could really increase the look and feel of our application is to use Tailwind CSS to make a really neat UI. So let's do that as well. We could go into our chat here and say, can you actually, let's include app.js as our current file, and say, can you add Tailwind CSS styles to make this application really look modern and clean? So now we're going to get Tailwind CSS styles added to our application. And let's see how Cody does here. So the updated version uses Tailwind CSS. We'll apply this. And while it's applying the changes, let's also just add Tailwind CSS to our application the old-fashioned way. So we'll do installation, and we could do this. We could ask Cody to generate the code for us, but I think it'll be quicker and easier to just add it ourselves. Where are we looking at? Render. Well, actually, let's ask Cody. So this is all working. So we'll accept that. And then we'll ask Cody, how can I add Tailwind CSS to this app? And we'll let Cody think for a second. And while Cody is doing that, we can simultaneously say add property, taxes, and homeowners insurance as input fields that will be calculated in the total monthly payment. So while this is working, we can also figure out how to add our Tailwind CSS classes. So I will copy this. We'll open up a new terminal window. And I'll just copy and paste. And again, we're doing all of this in the kind of chat-oriented programming where we're asking the LLM, looking at the output and applying it directly to our application without writing any of our own code. So we have a Tailwind config file here. We'll update it because this is a React application. And then finally, we'll go to our index.css, remove these styles, and then we will import that index.css, which is already being done. We'll hit accept here, and let's see if all of this worked. So module build failed, return outside of the function, and the reason that failed was we had a double return here, potentially. Actually, let's undo the change we had just for now. So all of our styles have been deleted. We might need to restart our application to kind of take in those new styles. And there we go. So now we have Tailwind CSS and a kind of much cleaner UI. Let's see if it still works the same. We'll add the same values, 5.5% interest rate. Interest rates might have gone down during this talk, hopefully. So check that out. We get our monthly payment. We get our amortization schedule. It looks much, much cleaner. And so this is looking really good. Let's go back and add that property insurance and escrow to, or our escrow information. So I'll open up a new chat window here. We don't need the whole repo. We just want to work in app.js. And let's say I want to include the property taxes and homeowners insurance. Add inputs for that and calculate total monthly payment. And again, we'll use Claude 3.5 Sonnet, but maybe for the next one, I'll switch it up just to show you that all of the LLMs give a pretty good answer. And while that is building out, I think there were a couple of questions to get to. So Neil asked, what features does Cody with your editor have that Cursor doesn't have? So Cursor is very similar to Cody in a lot of respects. I think one of the big differences is that Cody lives inside of your existing IDE. So here I'm using Visual Studio Code, but we also support any of the JetBrains IDEs. So, like Android Studio, IntelliJ, Golang, etc. So it's not its own standalone editor, but the feature set is pretty similar overall. You have chat, you have smart apply, you have code auto completions. And one of the big differences is you can use all of the supported models. You can also use local models with Cody. So if you have Ollama running, any Ollama models that you install locally, you can use for both chat and completions. We have a prompt library that you can share. So any features that your team might build that you want them to have access to quick prompts, as well as bringing in all sorts of different contexts. So here we were just using our local files, but we could also bring in linear issues, web URLs, and for enterprise customers, other external repositories as well. So those are kind of the big differences between the two. And let's see, Dave asked, is there any search engine integration? So if I want to ask a question and don't want to rely on the LLM training set only, it could get some web search results and include that in the context. So at the moment, there is not, there's not like a search engine integration by default. You could, like I mentioned, add web URLs. So, if you wanted to ask specific questions about a certain docs without having to go into a large number, without having to read the whole page, you could just bring in a web URL and ask, hey, could you do XYZ? And it's going to use that page as context. And then Janal asked, can Cody connect to organizational LLM? Could you clarify what you mean by organizational LLM? And while you do that, let's apply some of these latest changes and see if our application still works. So Cody is working. It's going to go and update all of the, adding the hazard insurance as well as the property taxes to our application. And let's see how well it does. I think last time it might have added an extra semicolon or an extra feature that made it not work. But here, let's try this again. If we go back. Okay, so now we have our mortgage calculator and we have annual property taxes, annual homeowners insurance, and let's see if that still works. So let's say 10,000 property taxes and 3,000 for homeowners insurance. So we get our breakdown now. Monthly mortgage payment is going to be $1,798, but our total monthly payment is going to be $2,881. So we have our payment, our principal and interest, and our balance, but we don't have the escrow here. So let's just, for fun, ask Cody to fix that for us as well. And we'll say, .js, can you include the escrow, taxes, and homeowners insurance in the amortization table as well? Thank you. Always be nice to the LLM. So YK followed up, if you mean things like Amazon Bedrock and Azure, then yes. And yeah, if you mean organizational LLMs as LLMs that you deploy and you kind of have control over, whether it's on Azure or Bedrock or a different provider altogether, we definitely support it. So we did this, and let's apply it. And that should be the last thing we'll do in this particular demo. But let's see how that changed. We'll accept all. And going back to our application, refresh, finally add our information. I was reading an article that said 40-year loans are going to be the new thing, so not quite ready for that. And let's see if this worked. So payment, principal, interest. So it did not add the additional field, but that's okay. We can go back and look at why it didn't do that and debug it further in this way. But I think we got a more interesting question. Can it create unit and integration tests, and can it also make a report on coverage? So it can definitely create unit tests, and we can do this a couple different ways. So if we start up a new chat window here, we have our prompts and commands. So prompts, like I said, are kind of custom features that you added, whereas commands, we have a number of built-in commands. For example, one of them is to generate unit tests. So if we just hit this generate unit test command button, what it's going to do is it's going to figure out which testing library we're using. And in this case, I already had an app.test that came pre-built with this React Starter application. And I asked it to generate unit tests. It opened up that file, app.test.js, and it added all of the unit tests for our mortgage calculator. So the first test was that it renders the calculator form, that it expects this following placeholder text, that it calculates the mortgage payment correctly, displays the amortization schedule, handles invalid input gracefully. And so it generated all of these tests for me. And I can just accept them and have all of the tests here, where then I could run them and make sure that my application is working as I make changes. And I could add additional tests if I wanted to, and I could do that either via asking Cody in the chat, or I can just add a another edit command saying add additional test for handling partial input, perhaps. I don't know if that would be a good test, but here handles partial input gracefully. We got the interest. We got the principal amount and the interest, but not the other information. And the error message that should be displayed is please fill in all the required fields to be in the document. So yeah, we could also do kind of test-driven development in this way, where we write our test first, and then we ask Cody to add the functionality to our application that will make these tests pass. So that is our mortgage calculator example. This was kind of building an application from scratch, kind of a greenfield application where we didn't have any existing legacy code. We didn't really need to, we didn't have the burden of understanding how the code base works. And so we were able to build this fun mortgage calculator application. It works, but let's do something a little more complicated. And I saw somebody asked about adding spaces in your Mac doc. I'll definitely, maybe in the follow-up email, I'll include instructions on how to do it. So Venki asked, assuming that I already have a unit test file, can I ask to check if I've missed some edge cases? You can definitely ask. So if we open up this file, and let's also include app.js, the app.js file, and say, what other unit tests would be valuable to add? So yeah, you can use Cody. We gave it the context of our test file as well as our implementation file, and asked for additional unit tests. So it came back and said, test for correct escrow calculations, test for input validation, test for correct amortization schedule, test for resetting, et cetera, et cetera. So yeah, you can definitely ask it, and you can also apply these tests. So if you're like, yes, I want to, I really want this test in my application. If you hit apply, it's going to go in and open the correct file and add the test for you. And kind of the one neat feature is that file does not have to be open. So if we're working in our application here in the app.js field, and we still want to apply the test for resetting our calculator, hitting the apply button is going to open up the app.test.js file where it should be added, and it's going to add that test for us. And again, giving us the control to accept or reject or change that implementation. Cool. So that is our CHOP mortgage calculator. Let's jump into a slightly different and a little bit more complex situation. So I will close out this folder, and I will open up this FFmpeg project that I've been working on. And I have a really annoying problem with this application. Basically, what this application does is it basically maintains a queue of video editing, processing, and clipping jobs. And it runs the job runs every 2 seconds if there are new jobs to be done. So if we look at this, find queue jobs command. So this command runs every 2 seconds, and it tries to find relevant downloading jobs, relevant clipping jobs, and relevant encoding jobs. When it finds them, it adds them to an array. Once we have the kind of array buffer filled, then we go promise all and execute these jobs. And then it restarts and does it all over again. So the code for it is pretty complex. If you're just jumping into this repo, you would look at it and be a little confused. But I have a very annoying problem here in that when I was first building this, I assumed that we would be getting maybe 30, 50, 100 jobs per day, and at that scale, it worked perfectly well. It was quick. Going to Redis, pulling in 100 keys and pulling in the hash information for those worked really, really well and really fast. But the problem here, if you're a Redis developer, you might be able to spot it. The issue is we are scanning and getting all of our keys, 100 at a time, but we could even do 1,000 or 10,000 at a time. Doesn't really matter. The problem is we're going to load all of the keys that we have in our Redis database, iterate over them, get all of their information, get their status, and then run the jobs. So the problem here is the queuing job, finding queue jobs function is going to take a very, very long time to execute on each cycle. And we don't want that. There are much better ways to do this. And I can go and read through the Redis docs and try to figure out how could I accomplish this task, or I could ask Cody to help me. So let's opt for that and hopefully get this done in 2 minutes, as opposed to spending hours on debugging and figuring out how to do it. So the question that I'm going to ask Cody is, my endpoints take a really long time to load. I think the issue is in the find queue, and I can actually even call out the exact symbol. So I can say find queue jobs function. Can you help me add a proper Redis queue, to speed all of this up? So we'll ask that question, and let's see what Cloud 3.5 Sonnet comes up with. So certainly I can help you improve the performance of your endpoints by implementing a proper Redis queue system. This will significantly speed up your operations and reduce the load on your main application. Here's how we can modify the find queue jobs function. So here we're gonna do, first let's create separate queues for each application. So we have our job types, download, clip, and encode. We're gonna modify the add download job and add encode job and similar functions to push the jobs to their respective queues instead of just creating a hash set or just a hash key value pair. And then we're gonna update our find queue jobs function to use this new functionality. So instead of, and then just to kind of summarize all of this, we're going to use separate Redis lists as queues for each job type. We're going to pop the jobs from these queues instead of scanning all of our keys, which is going to make things much, much faster. And then we're going to process the jobs immediately as they're found instead of waiting, waiting for each job to individually finish. And then we're still going to respect the job limit, 5 for download and clip and 2 for encode, to simplify the number of jobs and operations that we have running at once. So these changes will significantly reduce the time your endpoints take to load by eliminating the need for scanning all of the Redis keys. And the cool part about this is I have all of the functionality is already given to me. All I have to do is hit apply, and it's going to find the relevant places for creating these queues. So we can add that one here, this one for adding the download jobs is going to be added here. So this is for clipping. We can accept it, or we can go into the individual file and then update our find queue jobs function as well, which is going to be at the bottom. So we were able to, understand the issue, understand what the problem was, and get a working solution with our code without having to, kind of understand what the problem is, understand what our options are. Instead, Cody was able to give us all of the code and all of the implementation for this. And Camille here asked, how would you ask Cody to help you understand the application? What is the reasonable amount of files from repository added as context that it can handle? So this is a really good question, Camille. And let's get to it. So I will reject these changes for now, and let's open up a new chat. And here, I'm using, by default, whenever you open up a chat window, we'll import we'll add the entire repository as context and your current working file. But again, you can change this. And just by adding this video, this entire file, this entire repository does not mean that we're going to use all of the files that are in the repository as context. We're going to do an underlying search to find the most relevant files to include in the context. So let's say like we were trying to figure out why our application was running slowly. So I can ask Cody, hey, I'm having an issue with this application. It is running pretty slowly and taking a long time to load the informational endpoints. What are some ideas, or what are some opportunities for enhancement to increase the speed of my app? So by doing this, the first thing we do is we submit this question. Cody is going to pull in what it thinks is the most relevant context. And here we can see that Cody pulled in 19 different files. It pulled in the README file, the probe video file, the FFmpeg file, and then a couple of the package log.json, which probably aren't going to be very relevant, but they'll at least tell Cody what libraries we're using, and then the index.js, as well as public knowledge that Cody has about all of this. And the response that we get is, here are a couple of opportunities. One is to implement caching, optimize database queries, utilize async operations, implement request rate limiting, use worker threads, et cetera, et cetera. And the cool thing about here is Cody kind of gave us a general list of things that we can do, but we can also ask a follow-up and say, if I wanted to implement recommendation 5, how would I do that? So, Cody's going to be able to look at what recommendation 5 was, use worker threads for CPU intensive tasks, and it's going to give us an implementation. So to implement worker threads for CPU intensive tasks, here's what you would do. Here's where you would make those changes. And it gives me a bunch of code that I can add into my application, load it in, and see how it handles it and how it works. So yeah, you can definitely ask Cody to help you, and it's going to smartly and intelligibly find the relevant context from your code base and not load random files that aren't going to help you. And then finally, Richard asks, where do you see the future of documentation and understanding the code? Seems like we can utilize Cody to generate the document, but we can also use it to analyze the code and probably give more holistic view. This is another really, really great question. And so Cody has this amazing command that I use almost on a daily basis. Instead of reading all of this code, which I could sit and, kind of decipher and figure out what it's doing, we have this option.d to document. So hitting that, Cody is going to kind of give me a quick summary, find and process queues jobs from the Redis store, and it's going to explain to me in kind of simple English, in simple terms, what the function does, how it works, and what it's going to return, how it's going to work, et cetera, et cetera. I could even add a custom command, and I believe I have one that is going to do that. It's going to give me a slightly more detailed explanation of what the code does. Let's see if I have it here. Draft function, convert from TypeScript. Doc line by line. So I have this custom command that I built called doc line by line. And what it's going to do is it's going to document all of this code line by line for me, so that instead of having to read the code, I can very quickly scan and understand what the code is doing. And let's see how this works. So I will highlight the function in its entirety, and I'll click doc line by line. And Cody is going to go to work. It's going to document all of the interesting pieces of code for me, so I can accept all. And it's going to explain to me what it does line by line, kind of like explain like I'm 5 years old. This is going to create the iterator. This is going to initialize the array to store the keys, going through the keys, iterating through the jobs, et cetera, et cetera, et cetera. So this is another really powerful way to, in simple, English terms, understand what your code is doing. And this helps me find a ton of bugs as well, because, sometimes the way that you're writing code, it might be, overly verbose, especially if you're working in things like Rust, where, it takes a ton more time to kind of scan this and figure out what it's doing. Whereas I could just read and quickly generate, the explanation for what it's doing and how it's working. So really, really good questions there. And then finally, one last example I wanted to show, I know we are almost up on time, is working in a really, so that repository, has a couple hundred files, not the biggest application in the world. But the one that is really big is our Kodi VS Code extension. So this is an open source repository that has all of our, all of the code that powers the Kodi experience. And this has a ton of files, thousands and thousands of files, thousands of tests, implementations, working with different models, and so on and so forth. So if I'm a new developer that's been tasked, if I'm just onboarding and my use case is, I need to understand how I need to get a starting point for implementing a feature or debugging an issue, I can again use the entire Kodi repository as context and ask it a question, and it's going to tell me exactly which file to go to start making changes. So I talked earlier a little bit about that Kodi context. When you ask a question, it provides, which files it's using, and I can ask Kodi, where is this functionality implemented? So where is the functionality for displaying the context that Kodi pulls in for a chat? Where is the functionality? The context that Kodi pulls in for a chat located. So I will ask this question. It's going to figure out that we have 30 lines of context here, and we can see which files it used. And then I can also ask, we're seeing here that it's located in the simple chat panel provider. The simple chat panel provider class interacts with other components like the context status aggregator. And I could also ask another follow-up. So for the context types, for the context items that Kodi uses, what is the maximum file size a file can be? And I know we are just up on time, so let's see if we can figure that out. And here we can see that based on the codebase context provided, Kodi has a maximum file size limit of 1 megabytes or 1 million bytes. For context items, this can be seen in the following code snippet, file size, and we can actually, so this is in the helpers. So if we try to find the helpers here, that one, somewhere else, we could pull that actual file and make the changes to it or insert the code or apply it or change it. So if we wanted to say, ask a follow-up question, can we increase the file size to 2 megabytes? What are the implications? So again, fairly minor change, increasing the file size, but here are the implications of doing that. Larger context, increased memory usage, longer processing times, increased network usage, and possible impact on token limits. So another way to really kind of dive deeper into the changes that you're making and how they affect your overall code base. And with that, I think we are just up on the hour. I want to respect everybody's time. So thank you so much for joining me today. If you have any questions, please feel free to connect with us in the Discord community for Sourcegraph or our community forums, or feel free to shoot me an email at Ado Kukic at sourcegraph.com and give Cody a try. Cody.dev will take you directly to the Cody page. You can get it for your IDE, and we have a really good free tier. We have a really good pro and enterprise tiers. Give it a try. Let us know what you like. Let us know what you'd like improved or what features you'd like added, and we will see you next time. Thanks all.